So let's look at another example of using strong induction. And this is a more interesting example. Let's say that we have some monetary system and we only have a couple of denominations. So here we have a denomination of 3 credits and 5 credits. So like here in the US, we have $1 bills and occasionally $2 bills, $5 bills, $10 bills, etc. This particular monetary system only uses 3s and 5s, so 3 credits and 5 credits. What we want to show is that this monetary system works. Well, at least it works for any credit value greater than equal to 8. So in this example, we want to show that using 3 credits and 5 credits, we can make up any credit value greater than or equal to 8 using those couple of denominations. So the way that I'm going to show this is by using strong induction. So it's very helpful after we declare what proof technique we're using to define what our propositional function is. So here, they want us to show that any credit value greater than or equal to 8 can be made from these denominations. So if you were to give me a credit value n, then my propositional function that I'm trying to show that is true is that I can make n from 3 credits and 5 credits or combinations thereof. So here my propositional function is going to be n, some credit value that's greater than or equal to 8, can be made up using a combination of 3 credits and 5 credits. So from our strong induction definition, we need to show a base case. And similar to the previous example, the base case is not going to be 1 here because the n's, the credit values that we're talking about, are greater than or equal to 8. So the very first one that we need to consider is 8 itself. Because n is the smallest credit value that we are considering here, n equals 8. So we want to show that p of 8 is true. Well, what is p of 8 saying? That's saying 8 can be made using a combination of 3 credits and 5 credits. Well, that's pretty simple because 8 just equals 5 plus 3, right? So I can make up this credit value pretty easily. I just take one of my 3 credit denominations, one of my 5 credit denominations, combine them together, and I get 8. So my base case, pretty simple to prove. So now we get to our induction step. So here again, our induction step is going to look ever so slightly different because 1 is not the smallest thing that we're showing. We're starting at our smallest value is 8. So for our induction step, it looks as follows. We want to show that p of 8 and p of 9 and p of 10 all the way up to p of k implies p of k plus 1 for arbitrary k. So trying to show this for arbitrary k. So using a direct proof technique, we can assume this entire hypothesis. So we assume our entire hypothesis is true, and all we want to show is that p of k plus 1 is true. And what is p of k plus 1? That means that k plus 1 can be made up using a combination of 3 credits and 5 credits. So let's go ahead and consider k plus 1 real quick. That's some credit value, and I want to show that it can be written as a combination of 5 credits and 3 credits. So if we have k plus 1, note what we can do with this. So notice how I've trickily rearranged this. So k plus 1 is the same thing as k minus 2 plus 3. The reason why I pulled a 3 out is because 3 is one of our credit values here. And then note, really importantly, k minus 2, that is some value that shows up in this big ol' conjunctive statement right here. In fact, it shows up 2 steps before this very last one. So we assume this entire conjunctive statement is true, but we actually only need one of them. We assume that entire thing was true, so we assume this. We assumed that p of k minus 2 is true. So, while we assume that entire hypothesis, we only really need one of them. 2 steps back, p of k minus 2 is true. Why does this help us? Because we already know, we've assumed that k minus 2 can be written as some combination of 3 credits and 5 credits. So this can be written as a combination of 3 credits and 5 credits plus 3. So therefore, this entire thing can be written as a combination of 3 credits and 5 credits. Thus, that allows us to conclude that p of k plus 1 is true.